The standard form of rail used around the world is the flat-bottom rail. It has a wide base or foot and narrower top or head. The UK introduced a type of rail which was not used elsewhere apart from a few UK-designed railways. This was known as bullhead rail and is shown. Bullhead rail was originally designed with reuse in mind. It was intended that it would be turned over when the top had worn, but this proved impossible because the underside also wore where it had been secured to the sleeper. Bullhead rail has to be mounted in a special chair, made of cast iron and secured by a key wedged between the rail web and the chair. The chairs are secured to the sleepers by coach screws. Flat bottom rail is clipped to a base plate under the rail. Flat bottom rails can also be spiked directly to the sleepers. A wide-headed nail is driven into the sleeper on each side of the rail so that the foot of the rail is held by the heads of the spikes. Long stretches of track were laid in record times across the U.S. in the pioneering days of railroad development using this method of securing rails to ties. Nowadays, heavier loads and faster trains require more sophisticated systems. Normally, the rail rests on a cast steel plate which is screwed or bolted to the sleeper. The rail is attached to the plate by a system of clips or clamps, depending on the design. The older UK standard design was an elastic spike with a sprung, curved top which secures the rail. There are a number of variations seen around the world. One of the most popular is the pandrel clip seen above. A resilient pad will be provided between the rail and the base plate and around the securing clip. Where required to provide insulation for the track circuits if installed. A diagram showing the sections of different types of rail. The infrastructure-owning company in the UK, currently known as Network Rail, has adopted UIC 60 rail, which weighs 60 kg per m or 125 pounds, YD, as its standard for high-speed lines. The former standard is equivalent to the UIC 54 rail, which weighs about 113 pounds per YD or 54 kg per m. There are 2,400 sleepers, ties, in a mile of track. Older track is jointed. Much track is still jointed, although this is continuously falling as new rail is installed. Rails were normally laid in standard lengths bolted together by what are called fish plates in the UK or splices in the US. The joints allowed sufficient space for expansion as they were provided at 60-foot intervals in the UK and 39-foot in the US, allowing them to be carried in a standard 40-foot flat wagon. The joints were always staggered in the US, whereas the UK placed them side by side. The result of the US staggered joints can be seen in the curious rolling motion of freight cars running on poorly maintained track. The reason for the staggering is that, in the US, it was determined that after jointed rail has been in place for a time, it starts to drop and creates a depression. When a wheel falls into the depression and begins to climb out again, it exerts a force. If the two joints were in parallel, this force would be much larger, and the joints might snap. This is not considered a problem in the UK and Europe, probably because of the lighter axle loads. Nowadays, rail is welded into long lengths, which can be up to several hundred meters long. Expansion is minimized by installing and securing the rails in tension. Provided the tension is adjusted to the correct level, equivalent to a suitable rail temperature level, expansion joints are not normally needed. Special joints to allow rail adjustment are provided at suitable locations as shown. Adjustment switches are also provided to protect turnouts, and at locations where a change in the rail design or size occurs. Rail expansion and contraction under changing temperatures is discussed by Rail Engineer magazine. In order to allow adjustment of rail lengths under changes of temperature, special expansion switches are inserted in suitable locations. The sleepers are separately secured to prevent movement. Rail tends to creep in the main direction of travel, so rail anchors, anti-creepers, in the US, are installed at intervals along the track. They are fitted under the rail against a base plate to act as a stop against movement. Rail welding. Modern track work uses long welded rail lengths to provide a better ride, reduce wear, reduce damage to trains, and eliminate the noise associated with rail joints. Rail welding is a complex art, or science, depending on how you feel about it. There are two main types of welding used for rails: thermit welding and flash but welding.